Hello everyone.
I am myself Kushal Verma from Mechanical Engineering, second year regular. So today I'm gonna explain about connection types of a three-phase transformer. So first of all, what's a three-phase transformer? Three-phase transformers are used to step up or step down the high voltages in various stages of power transmission system. A three-phase transformer is made of three sets of primary and a secondary windings. Each set of wound around one leg of an iron core assembly. Essentially, it looks like three single-phase transformers sharing a joint core as in a figure. Uh, so there are four types of connections for a three-phase transformer. They are uh, star to delta, delta to star, delta to delta, star to star. So, delta to star. The primary winding is a star-star connection with grounded neutral, and the secondary winding is a delta connected. This connection is mainly used in step-down transformers at the substation end of the transmission line. The ratio of the secondary to primary line voltage is 1 by third times of the transmission ratio. There is a 30-degree shift in the primary and secondary line voltages. So, connection of a star to delta. The star connections are mainly required for the power transmission network for longer distances, whereas in delta connection mainly in distribution networks and it is used for shorter distances. Delta to star. The primary winding is connected in delta and the secondary winding is connected in star with neutral grounded. Thus, it can provide three-phase, four-wire service. This type of connection is mainly used in step-up transformers at the beginning of the transmission line. The ratio of the secondary to primary line voltage is 3 times the transformation ratio. There is a 30-degree shift between the primary and secondary line voltages. Now the connection of delta to star. Star to delta starters. You can actually reduce energy consumption. How? How can we reduce energy consumption? Well, during the starting phase of the motor, the starter connects the motor windings in a star configuration, which reduces the voltage across each winding. This means lower current flow and less power consumption. Star to star. Star to star connection is generally used for small high voltage transformers. Because of star connection number, uh, the number of required turns phase is reduced as the voltage in star connection is 1 by third terms of the line voltage only. Thus, the amount of insulation required is also reduced. The ratio of line voltages on the primary side and the secondary side is equal to the transformation ratio of the transformers. Line voltages on both sides are in phase with each other. This connection can be used only if the connected load is balanced. Star to star connection. A star connection is a connection used in a polyphase electrical device or a system of devices in which the windings each have one end of connected to a common junction and the other end to a separate terminal. Delta to delta. The primary winding is a star connection with a grounded neutral. The secondary winding is delta connected. The connection is mainly used in step down transformers at the substation end of the transmission line. The ratio of the secondary to primary line voltage is 1 by third times of the transmission ratio. There is a 30-degree shift between the primary and secondary line voltages. Delta to delta connection, pictorial representation. This connection is economical for large and low voltage transformers in which the insulation problem is not so urgent because it increases the number of turns by phase. This is the picture how a delta to delta connection is connected. Advantages of a three-phase transformer. What are the advantages? There are numerous advantages of by using a three-phase transformation, which can be listed below. Inexpensive, single phase inexpensive, and it is very inexpensive compared to a single phase transformer. The three phase transformer comes at a cheaper price. It has a low cost when compared with the three units of a single phase transformer. Lightweight. Not only the transformer is lightweight, it is also smaller than a single phase transformer in size, which it means it also occupies less space. Assembly in least time. It is extremely easy to assemble. We can get a single phase supply from a three phase transformer, while opposite is not possible. We cannot get a higher efficiency. The three phase transformer performs its functions more efficiently and delivers more power than a single phase transformer. Easier to install. The three phase transformers are pre-wired and ready to install, thus makes the installation process very easy and smooth. Easy transportation. In order to provide the same output, the material used for building the core of a transformer is very little as compared to a bank of three single phase transformers. Not only transportation easy, but is also reduces the transportation cost. Disadvantages. Greater cost by standby units. The individual cost of a standby unit is high and makes it difficult to repair or to fix any malfunctions in a three-phase transformer. A common core is shared by all three units. Therefore, the unit is defective or damaged, the entire three-phase transformer has to be shut down. Cost of repair. The cost to repair a three-phase transformer is higher since the changing of individual component is expensive. Hence, to restore the service, the spare unit cost is much more higher than compared to a single-phase transformer. Reduced capacity. Since the three-phase transformers are self-cooled, the capacity of the transformer also reduces simultaneously. Fault correction. In case there is a fault in any of the phases of the three-phase transformer, the fault is transferred to the another two phases. As a result, the whole unit should be replaced. Applications. In it is used in stepping up the voltage at a generation side before the transmission and distribution. In distribution side, for commercial and domestic use of electricity, transformer step down can also be done in the level of voltage. For example, 11 kV to 220 volts single phase and 440 volt three phase. The current transformer and the potential transformer